Hi guys, welcome to the series of lectures on preparation for machine learning. This series will be mainly focused on giving you an exposure and basic understanding of the workflow or the pipeline of machine learning. And also it will help us to identify the requirements for us or else for everyone mostly to uh, plan our career into machine learning. So let's jump on. I'll be using Google Colab and project 1 or the lecture 1. I'll be focusing on one of the categories of machine learning or the mostly widely used machine learning, supervised learning, and we'll be working on a simple linear regression. As a beginners, if you think that it's a bit of confusing, just forget it. It's a simple understanding is that if you search for machine learning, you can see that machine learning is the study of computer algorithms that can improve automatically through experience and by the use of data. This is the word you need to keep in mind. Based on the data, we can start predicting the outcomes. That's what you need to understand as an initial starters or the beginners. And also, it really helps you to understand that why the giants like Amazon and Facebook, they are rich because they got the data. Then in machine learning, we'll be focusing on the widely used category, which is supervised learning. And once again, if you see here in supervised learning, it says a model can predict the outcome on the basis of prior experiences. Okay, that's one thing. There are so many detailed explanations about supervised learning is that right now I can simply say that with the label data, we know the independent and the dependent variables. So based on that one, in future we can predict based on the previous data. I'll show you one example and downloads. This is the data we'll be working on. It's a very simple, basic, limited, small data where we'll be working on two variables, two columns, we can say. One is years of experience and salary. Because as we are going to work on only two variables, it's simple. So that's why we can say that it's a simple linear regression. We'll go through a little bit about linear. We'll talk about linear later. But regression, why regression? Regression is because we are going to predict the outcome based on numerical values. Here if you see, based on the experience, we are going to predict the salary. Here you can see the number, numerical value. That's the reason we call it as regression. We'll go more in detail as we take furthermore steps into this series. And also we'll learn more libraries and algorithms at a basic level. We don't want to make our life complicated. We'll do more complicated works in the second series, which is in the mid-level. And the third series will be a competitions. Right, so let's jump on to Google, and I'm going to use Google Colab for this project. You can use PyCharm or Google Notebook, Jupyter Notebook, but I prefer Google Colab for this project as initial starters or the beginners. We don't need to have any pressure of planning how we can install our libraries and all sorts of stuff. We just need to input the libraries. That is the flexibility of Google Colab. Yeah, we have some advantages in Jupyter Notebook, but I will work on Jupyter Notebook also in future projects. So today we are going to work on Google Colab. So you just need a good internet, that's the only thing, or a decent internet. So what we'll do is that we'll click on Google Colab, search for Google Colab, You just need a Gmail account, and here, because I already logged in, okay, I already logged in, so I can click on create new notebook. It will take a bit time. Now here, first I always better to name it. I'll put simple linear regression underscore project. Enter. So if you see here, if you click on file, locate in drive, you can locate this project in the drive. Right now it's called Untitled because we have yet to save it. So click on file, save it. The moment you save it, if you go back to your drive, you should see simple linear regression. Now we don't have any data, all those things, we'll work on it. First step, we need to import our libraries. So I'll comment import libraries. If you don't have a prior experience of Python, but still you can start working on it. You just need to understand how the comment is written here with the hash. And then once again, if you want to work on Python, I have a playlist of Python for the basics required for data science. You can always look into that one. I'll put import numpy as np. What is numpy? We'll go more in detail in the future series. Right now you just need to understand numpy is a numerical Python series, and which gives a lot of advantages when we are working on the numbers, or we can say numerical values. And then we'll import pandas as pd. It's a library, a very powerful library within Python, where we can work on the data and data frames. That's what you need to understand right now. And import matplotlib.pyplot as plt. Okay, it is for the visualization of the data. That's the only thing. For the time being, you just need to understand it's for the visualization. That's it. Shift enter. I could have just clicked on this play button, but rather than play button, I like to click shift enter so that it will execute this cell and create a new cell. Good, got it? The next thing is that we need to connect our Google Colab with the drive so that we can access the data. So right now we don't have any data. So let's get our data. Your data, I could have given you on GitHub, but no, I want you to work as a beginner. So go to Kaggle, okay, Kaggle, and we can create an account. It's a free account. It's first step into understanding and getting into the world of data science. Here, search for, you can search for, let's take, you can Google, you can search Kaggle salary dataset. You can see it's, this is where you get it. Okay, can you see? The best one is years of experience and salary dataset. Okay, you can do anything. Got it? Download this dataset and extract the file. Then once you extract it, I've extracted the file. Go to your drive and drag and dump it into your drive. So you got your data here. So we don't need much of work with Google Drive. So first thing, we need to click create a access. So we'll put from google.colab import. If you just give some sum, it will start recommending based on IntelliSense. So import drive, and later next line we'll put drive dot mount in brackets, in quotes you can put slash content slash drive. So we are creating an access through this one. So click on Shift Enter. So when you click on Enter, it will ask you for the permissions. Always you need to give the permission, and this one, select the email and allow. So it takes a bit of time for it to connect it to the drive. It's mounted. If you expand using this folder, you can see the drive. If you start expanding this drive, my drive and collab notebook, you can see the salary data. This is where we have uploaded our data. Can you see? Now we'll start reading the data. How to read the data? You can put DF or data sets, whatever you call it, but generally we prefer going for DF because it's a commonly used terminology for reading the data and storing it in a variable. The variable name is DF. So PD, we are using pandas and we are using the alias as PD, and then read. So read CSV and quotes. In quotes, we need to give the path and the file name of this data. So click on this 3 dots and copy the path and paste it here. Got it? And Shift Enter. Now the data is read and stored in DF. Now we'll do some exploration. Means we'll try to understand the features and all sorts of information which we need from this data. So I'll put df dot shape. Shape is a property. Okay, if you see, just leave it, it will leave it, and enter, Shift Enter. So right now it's saying that we got 30 and 2. 30 is the rows and 2 is the columns. If you come back to your data, you can clearly see there are 30 rows and 2 columns. And years of experience is a dependent. It's on its own, whereas salary is dependent on years of experience. So we got a dependent and an independent variable. And as we are trying to create a relationship, trying to understand the relationship between the dependent and the independent variable, that is why it is called a simple linear regression. We'll try to understand a little bit more in what is the linear thing. Okay. So let's come back here. So we got shape. The next one we will use it's a method. It's called head. So if you if you type df dot head and enter, it will display the top or the first 5 rows. Can you see years of experience, salary, and it starts with 0 and 4. The same thing if you put tail, you should know it displays the last 5 rows. Good. Now, as these are methods, you can overload it with the number. So if you put, let's say 2 and Shift Enter, it will display the last 2 rows. Got it? And then the next thing we'll use, the next method is info. And by the title only, you should know it will give the information. If you leave it for the timing, this method prints information about the data frame, including the index type and columns and non-null values and memory usage, everything. Can you see? It has given all the information. We got 2 columns. The important stuff, what you need to understand right now is that no null count. The non-null count means it's 30 non-null count. Means there are 30 rows, we know, and 30 rows are with information. There is no row without, which is an empty row, nan value, something else. Okay, so that is good for us. So next step, what we will do is that we got something called describe. If you put describe method, it describes the data. Each individual column it is describing. It's saying that years of experience, it has got 30 rows and the mean is 5.313. Now, what is mean? I think you should know. If you don't know, it's adding all the values in years of experience divided by the number of elements. STD is a standard deviation. once again, it's the variation. I don't want to say it's a variation, but it's a change in the slope and all things. We'll go more detail about standard deviation and all things in the future studies lectures. And the minimum is the minimum value and the maximum value and the quartiles. This is just for you to give some explanation. Right now, it's a very simple data, so that's fine. So next thing is that you don't need to identify it because we are only 2 rows. We don't need to go into columns and also we got it. So there's one more thing is called df.is null. Means we are saying that in this data, is there any null values? We already know in the information it's not there, but I just want to show you. Oh, sorry. Yeah. If you see here, false means no, this is not a null value. This is not a null, but this is too much. I can just put here sum. Sum means added everything, and if there are any years of experience, there are no null values, and salary, there are no null values. That's good. So we will use this Matplotlib to display or to visualize the relationship between the 2 variables. So I'll use scatter, okay, and I'll put x equals df. Generally for the x-axis we use the independent variable, which is years of experience. Correct? And in y-axis we will use salary. For the time being, I'm just putting plt.scatter, and the next line we'll put plt.show. Now it is showing, it is plotting all the dots, all the data points on the axis, and if you see experience, and this is salary. It's a bit not clear, so I can put plt dot x label, and I can put always this is y label, and we'll use salary. And if I run it, this is salary and this is experience, and you can see that it's a linear relationship. Means linear means as the experience is growing, you can see the rise in the salary, and you can predict a best fit line, a straight line, where we can say that we can identify a best fit line. That is why it's called simple linear regression. Now let's split the data, because right now we got the whole data in one data frame, so we need to split it into the dependent variables, independent variable, and then a dependent. So how to do it? So come here and say x equals df dot iloc, and first type the code, then column, comma, and then I'll put column -1. So what I'm saying is that from the location from the starting to the ending, so everything, comma, and as per the rows is concerned, so columns is concerned, starting, leaving the last one. Now you could have just put RAM, you could have just put a 0 because it's a 0th column. You can do it, but right now we don't want to take it like this and convert into matrix. This is the best way you can do it. And the y thing, in y I'll use the same thing, but here because I need a vector, I'll just put -1. I'll remove it like this. Okay, and if you see for x I'm using capital X, and for y I'm using the lowercase. It is once again the basic style, the terminology which we use widely, mainly because x is the independent variables, okay, and it's a matrix, and y is a dependent variable, and which is where we are going to predict it. It's a wet vector. So enter. Now if you want to see x dot shape, it has got 30 rows and 1 column. But whereas if you go for y shape, it should be saying the same thing, 30 rows and 1, but it won't say 1, it will just say 30 comma, because by default it will have only 0th and 1 element. Next thing, we got 2 separate data. Now we need to split the data, which is the independent variables and the dependent variables, into test and train, because we will take the whole data and take some part, I can say nearly 70% or 80%, whatever the part you want, and train your algorithm, and then you can test it, because we know both the values right now, the experience and the salary, so we can start comparing it. And when we can compare and we can identify that it's really working well, then we can start predicting the other outcomes. So let's split it. To how to do it? First we need to get from sklearn model selection import train. I'm just waiting to say that. So this is the module. We'll import it, and then we'll put x train comma x test, y train, and y test. Means using this train test method, we can break our dependent and dependent variables into our test and train data. So how to do it? Train, in brackets we put x and y, because it's the data we know. X is the independent variable and y is the dependent variable, and then here I'll put test size 0.3. Right, so what happens here is that we are dividing the whole thing. The test size will be 30% and the trained data will be 70%. Can you see? Now shift enter, and if you want to check the shape, you will not check the shape on x, you will check on x train dot shape. We will have 21, because 70% of 30 is 21, and x test 9. So if you add it 30, the same thing will be, you can see it on here. Now we will train on this data and test it on the test data. So we need to train this one. So how to train it? First we need to get the linear regression algorithm. So we'll import it from sklearn dot linear model import linear regression. Linear regression is, you know, y is mx plus c, which is slope and intercept. We're trying to identify the y, the dependent variable. So here we can come out with we'll create an object of linear regression. Right, so we have created an object. Once we create an object, now we'll use it, we'll fit it, we'll fit with x train, right, and then y train, because if you see, x train is the independent variable and y train is the dependent variable. So we know, we are saying that this is the information, this is dependent, and this is what the outcome which are linked. Okay, so now let's see, we start doing some predictions. So let's come back here and say y pred. Okay, once again, most of the terminology which I'm using is I'm following most of the information which is a lot of other people or a lot of tutorials and helplines, they use it. So that's the best way to continue with it. So here I'll put ella dot predict. and I'm predicting on X test because I've trained it based on the trained data. Now I'm predicting on the X test. So whatever predictions is there, then we can compare it with Y test. Got it? So this is the predictions based on this X value. We are predicting this value and then we can compare it. So let's if you want to just roughly check it out, you can say these are the values. Can you see it's saying that 1, 1, 8 and all that. But let's take, if I print Y test, the original value is this value, but the algorithm is predicting that the offer should be made 118,000, 63,000, 48,000, 34, 39, 81, 81. Oh, good. 101, 101. Got it? It's roughly showing. But if you want to compare it, we'll do one thing. We'll say PD data frame. Okay. Got it? And then I'll put np.c underscore X test. Okay. And then Y test. These are the original values. And then we can put Y pred. What is C underscore is concatenate. We are concatenating all this information. And then in columns, we put the values equals. Columns means we want to give some title, so we can say that we can say years experience, and I'm going to just put years X, and then salary, original, this is the original salary, and then this is the pred salary, and shift enter. If you see, this is the original data based on our data, and then these are the prediction salaries. And if you see, if you have 2 years experience, the original salary is 43,000 and it's predicting 43,000. In some places you can see a big spike where this person, number 7, did a very good negotiation, so he got 60, but generally prediction is around 53 or 54,000. But whereas this gentleman or anyone with a 9.6 experiences, he should be offered 118, but he's getting 112. But this is what. So this is how you can say it. Okay. Now let's what we do is we take a little bit step forward. We want to see the score, means at what percentage my algorithm is giving the results. So let's take, if I put X, sorry, not what X, LR dot score. Okay, I'll put X test and Y test. Means I'm comparing the score between X test and Y test. Okay, it's giving 96%. It means it's predicting based on this algorithm. The prediction is nearly 96%. You're nearly right, nearly there. So let's see. We'll try to plot it because we would like to plot something like this and then check it. So I'll just copy this lines and paste it here, and here rather than I'll just remove everything and I'll put X train, Y train. So I'm going to plot the training data, and then also what I'll do, I'll put color green, and the next line I'll put plt dot plot. This time I'm plotting the line, the best fit line. So what I can do is that I'll put X train. This is because this is what we need to use, because this is the prediction line. Okay, so lr dot predict. Here you're going to put X train. Got it? And then color we'll use red. See, can you see the points are always near close to this red line. This is the linear line. Okay, that's the reason it's called simple linear regression. So this is what it's happening. Perfect. If you want, you can always give title and you can put training data. Means this is a visualization of the training data. You can use the same thing, but this time rather than using train, we'll use test. That's it. You don't need to change this one because the predictions are being made on the training data. Okay, now enter. Once again, you can see they're very close to the linear line. So I think this is good. Let's take what we'll do is that we can always use lr.predict in brackets, and as we are using matrix, so we need to use double brackets. And let's take, I want to predict with a 3 years experience. I can put number 3. It's saying that 53,438. 53,000. Got it? So you can directly, in future, you can always give the value. Let's take somebody has applied for a job and then he has 5 years experience. So I can predict it. So I can start negotiating from 73,000. That is from your business purpose. You can say that this is my offer for you. Then the negotiation starts. Now, it's a linear regression. The concept is y equals mx plus c. That is a concept. Huh? Y equals mx plus c. Now, y is dependent variable, x is independent variable, m is the slope or the coefficient, and c is for the intercept. So let's take, if I want, I can always, using this linear regression things, LR model, we can always get, let's take m equals LR dot coefficient, come on, and then c equals LR dot y-intercept. Okay, it's called intercept. It's y-intercept. So now I got these values. So let's take, I want to predict a y value. I'm going to use the same style. Let's take 5. M is m because we just now got the coefficient. Then multiplied by a value of 5 years experience, plus c, which we have just now. And then if I print it, 73,000. So this is the equation. This is how we are predicting it. Got it? So any questions, anything, always feel free to get back to me. It's a simple way you'll understand, but I'll skim through it once again. These are the libraries, and we have imported 2 more libraries here and here, and we got the data, and we did some exploration, and then we plotted to see the relationship between years of experience salary, and you can easily see it's proper linear relationship, linear positive relationship. And we split the data into the test and train, not test and train, x dependent and independent variables. Later with the input test and train and test, we split the data, and then we use the regression model, and then finally we predicted. We can always, in future, if you want to use this model, we don't need to run the whole code. We can always use a simple pickle library. Okay, you can always save it. So let's take, I can put input pickle. So here what we'll do is that with open quotes, this is where we need to save our model. So I can just click on copy path and slash. I can put salary underscore pred underscore model, and then you can come back here, and in quotes we'll put WP. Means we are going to write a binary file. Okay, this is the path and the name. You don't need to give the extension because we are going to work on pickle, so it will by default it will save as a pickle file and as. Now then here I'll put pickle dot dump. So we are going to dump this linear model which we just did it, if you see here, and then from this file, as if this file, and if I press shift enter, you should see the model here. It will take some time. Just open it, it's there. Can you see? Now to open this file, once again we can just copy. I'll just copy these lines because in future, let's take you got a new Google Colab. You don't need to get all these things. You just need to import your libraries, and then you can just come back here and say that with open. Here you'll put RB read binary, okay, and then rather than pickle dump, we'll put model equals, okay, pickle dot load. Got it? So we are loading this file, this model, which we just saved into this model. So let's take, why I'm showing you, because here if you see here, we are predictor like this. So we can do the same thing with this model and type model dot predict, and then I'll put fine. Can you see? It's predicting properly. So with this just one file and the libraries, whichever libraries you wanted, you added. It's a simple document, so you don't need to train everything. The whole binary information is in this file. Okay, so hope you enjoyed this lecture, and I'll see you soon with more some more basics before we start learning NumPy and pandas and all sorts of Matplotlib, Seaborn. But for the first few sessions, we'll be working on the mini projects. We'll be doing one more linear regression mini project, and once again a simple linear regression, and also we'll try to work on a logistic regression, a classic classification model. Okay, regression model and classification model, and then we'll jump on to a little bit more in detail. So that is our target for the next fortnight. In next 15 days, we'll try to go through and understand the basics, and we prepare ourselves for the real big journey. Okay, any questions, any queries, feel free to email me or message me. Thank you, bye, and take care.